We have heard a lot about universal CPE and NFV, and this is what I hear a lot. They're doomed. It's too hard. There's thunderstorms and lightning and tides and can't be done. I hear this all the time. And how many of you are familiar with the notion of a existence proof? Greg, what's an existence proof? No, not quite, no. An existence proof, so if you look in mathematics, or sometimes you can go to a lot of steps to prove something exists, or you can just show it. Now, however it got there, it doesn't matter. It exists. That's an existence proof. So we have some people here from Verizon, and I'll use Verizon's example of an existence proof. This is being done. This is being rolled out. People are winning business with universal CPE. We hear all these problems, and recently this effort for lean NFV to solve some of the problems. And look at that guy up there. Service providers grapple with VNF islands, turbulence, 6-year itch. It has been a long path, and we hear all kinds of problems. We can't meet the performance using a white box, so stop. The commercials don't work. We can't make the business case work. I had to have some words with my friend Ray Watson at Masergy talking about how many VNFs were needed to make the business case work on a white box. Ray's a lot of fun. He always stirs things up. It's not deployable. We can't take these technologies from the cloud and move it out into the network. And it's too complicated. It's too hard. And so I say to this nonsense, presenting an existence proof. It is being done. NFV is real. Why can I say that? Because it is being done. There's been a lot of talk about centralized versus distributed. And if you look back at the early days of NFV, people were saying, hey, we've got these data centers, we've got these VMware clouds, we're just going to spin up stuff in the data center and virtualize it there, and you don't need to have any box at the customer prem. And that's not true. And there's another group that said, well, everything has to go at the customer prem to make it scalable. Our answer is both. Put the functions where they need to go based on cost, performance, and requirements. It's not a theological discussion, it's an engineering discussion. Should you have a pure play COTS white box server or a hybrid? And just as examples of those, so our customer Verizon is deploying a pure play COTS server. They go out and buy a commercial server from a variety of vendors. You look at the competition, AT&T, there with their FlexWare, that's a hybrid. That combines a switch chip and a server blade. They both have advantages. Within ADVA, our group sells software, but ADVA proper also sells hybrid devices, hybrid CPE devices that combine our best-of-breed NID with a compute blade. They're both viable solutions. Which one do you pick? Well, it depends on the requirements. If you need a very low-end deployment, then chances are you're going to need the cheapest white box you can get. But if you need capabilities like very high throughput or sync and timing or encryption or extended temperature, you may need the hybrid. We talked a little bit about this earlier. I think Vishal raised the issue of who's the integrator. Should we be getting everything from one company or have a set of components that we're putting together? And the answer is both. If you're a tier 1 operator like a Verizon or an AT&T, you are the integrator. If you're a tier 2 or a tier 3 or an enterprise, you're probably looking to a VAR, a system integrator, or somebody like an IBM to put the solution together and give it to you. But even in the latter case, you're still getting a solution that's made of best-of-breed components that could be changed later. So you don't have to put the whole thing together, but if at some point you need to take out the SD-WAN from one supplier and stick in another one from another supplier, you could do it. Does the business case work? Yes, absolutely. We're seeing now that it doesn't take very much to have a solution that competes with just delivering today's service. So that's what people have to make the business case work on. I'm replacing a stack of boxes for today's service with a virtualized implementation for today's service. That business case has to work, and it does. But here's the upside. If you can make that work, then you've got this platform for innovation. You can layer on all these other services. I'll tell you a really interesting aspect of this is try before you buy. I was talking to an operator and they said their experience is if you have a try before you buy service, they get about a 80% or so take rate. The problem is you have to take a box out to the customer and print, and in that 20% of the cases you have to bring it back. Now, what if instead of having to deliver a box, you could give somebody a software upgrade on a try before you buy basis at essentially no incremental cost, and you got an 80% take rate? That is a compelling application because you can drive new revenue easily. And we know that it works. I mean, if you look at all these software as a service platforms or music service or any service that you get on the internet, it's always 30 days free, 45 days free, whatever free, because the incremental cost is low and the take rate is high. So this is a great business model. Is it deployed? Yes, we've been deploying with Masergy for over 3 years now on 6 continents. I don't think we've got a deployment yet on Antarctica, but they may have one before too long. And do we have any compelling use cases? And the answer is yes, and I'll go through some of those. So, but let's go all the way back to the beginning and remember why we started. If you go back and you think about why telcos want to leverage cloud technologies, you can actually expand this to enterprises also. This all started back in the NFV days where the operators were seeing that there was all this innovation going on in the cloud, and they wanted to get a piece of that. So they got together and they invented NFV. And it was about CapEx and OpEx savings, but it was about more than that. So here's some of the things that we think are important and we keep in mind when we're driving these solutions for our customers, that part of this is being able to move much faster and be able to develop new services with a software upgrade instead of changing boxes. Being able to deploy service instantly, not waiting on a wireline. And what I mean by that is, by moving these white box servers, you can get these with LTE cards in them. So now think about today, you want to open up a new store for your chain, and you call up the operator and they say, okay, fine, we'll get you service in 45 days, 60 days, I don't know, maybe 90 days. You'll get it when you get it. Versus, okay, we will drop ship a server to you tomorrow. It will have an LTE interface so we can turn you up tomorrow. You won't have your full bandwidth, but you'll have service tomorrow. And then in 30 or 45 days, you'll get wireline service, and then the LTE will be a backup. Moving from telco time to internet time. That is a powerful, powerful story. I talked a little bit about the try before you buy. The other side of that is pay for what you use. So think about the case where you're a company and you're going through an M&A and you need to spin up a bunch of new sites for the company you're acquiring on your VPN, and you need to go out and add 50 sites for 6 months because after 6 months there's only going to be 25 sites, or maybe you're going to move them over to your technology, whatever. Being able to do services on demand for fairly short amounts of time is very valuable. But also look at it from the operator standpoint. Now you're not having to have a bunch of inventory sitting in the warehouse. You're buying licenses on demand from your VNF suppliers and using them to spin up services. And then if somebody goes off or closes an office, you reclaim that license and stop paying for it. So that radically changes the cost equation for deploying services. We're seeing tremendous growth in the processing power of these servers. There's been talk about the end of Moore's Law, but they're still getting faster and faster and cheaper every year. By decoupling the hardware and the software from the services, you can now ride that curve. And then finally, being able to work in a partnership model. There was a question earlier about when you're doing the integration, who is doing the integration and the support and all that? Well, in some cases, it's the operator, in some cases it's an SI, but fundamentally to get the full value of this, you need to have the suppliers, the operator, and the customer willing to work together so that when the customer says, hey, Mr. Operator, I've got a real problem I need to solve, instead of them saying, oh, okay, I'll get back to you in 2 years, they say, let me pull my partners together and let's put something together and we can give you a trial of something, say in 6 weeks, and if that works, then we'll productize it and roll it out to the rest of your sites, but we're not going to make a big investment until we know that what we're proposing can work for you. That is a fundamentally different way of operating. And I've got a link here to the original NFV white paper, and it's old now, but I still think it is a very good intro to the point of all of this, and it's worth looking at that once in a while and remind yourself, why are we doing this? I've been using variants of this picture for a long time, and I see universal CPE as the perfect instantiation of NFV at the edge of the network. We're bringing the power of the cloud to, I say edge cloud, to telcos. And it's a very simple graphic. On the one hand, you've got the old way of working, which is a stack of appliances. And on the other side, you've got a set of applications being loaded dynamically onto a standard server. I show this to people and they get it. This is a really simple picture, but it captures the fundamental value of what we're doing. Replacing appliances, choice of software, hosted wherever you want, and open hardware. That's it in a nutshell. So there was a question that came up here, what's universal? So my opinion is that when we say universal, we're saying that by putting one device at the edge of the network, in this case a server, we can host any application. And Javier Francisco earlier said, or Francisco Javier said earlier, that he was seeing a bit of a difference between the hosting for NFV and the hosting for cloud applications. And because NFV needs to have dedicated resources, which is true, and you need to add them incrementally, and the applications can share resources and can be oversubscribed like they are in the cloud, and you kind of need to treat those differently. Well, I would differ on this one point, and that is, once you put this open server out at the edge of the network and it's sitting on a customer prem, you can have part of the resources dedicated for running networking applications like SD-WAN and firewall. You can take other resources and let them be allocated to the customer on an oversubscribed basis for their own applications in a micro cloud. That also is a very powerful story because now you can think about not only putting in applications for networking, but giving the end user the ability to retire their crappy old servers that are sitting in the 7-Eleven running the lottery machine display and the gas pumps, replace those with VNFs running in a VM on that server. They no longer have hardware to maintain on the site. It's incremental revenue for the operator, all on one device that can be right-sized for the application. Some of it in dedicated resources, some of it in oversubscribed. It's all easy to do, almost say easy, it's all very doable if you stick to the fundamental principles of openness, basing it on standard cloud infrastructure, and remembering that in order to really see the benefits, we need to make this edge cloud look like the data center cloud. All right, so here's my view of what's driving edge cloud. And by the way, you'll notice that probably the last time any of you saw me speak, it would have said Ensemble down there. Now it says edge cloud. Ensemble is still our software brand. So our Ensemble Connector, Orchestrator, and Virtualization Director are our software products, but our group has been renamed Edge Cloud. And partly that's because we're seeing this tremendous embracing of distributed compute through the network, not only to host NFV in a universal CPE application, but also for IoT and AI and ML and 5G and everything else. So here we have Edge Cloud. So the first thing that's driving it is today's services. Replace a stack of boxes with SD-WAN and firewall running as VNFs on a standard server. And then we get the benefits that we were talking about, the openness, the multi-vendor, the scalable cost. So that's what's driving it. But then here's what's really interesting is the benefits we get out is being able to move forward. Today, most of the VNFs are running in virtual machines. We support containers, and we're starting to see the advent of some containerized applications. The interesting ones to start with are virtual test agents. We're seeing the ability to spin up a test agent to do a service verification, troubleshooting, in-service monitoring. The serverless model of IoT, if you look at the AWS Greengrass gateway, they pitch that as serverless compute where you can spin up jobs to interact with the IoT devices without having to know anything about servers or VMs or anything like that. I mentioned the microcloud, the 5G, IoT, and industrial IoT. The latter one is really interesting if you're monitoring this notion of IT-OT convergence, where industrial applications, manufacturing, hardened applications, they have one set of infrastructure for controlling these machines. And then the same company will have IT infrastructure, and it's completely separate. They want to bring those together. Universal CPE is an ideal way to do that. And then AI, ML, OT, all those. So here's my definition of edge cloud. So starting off, we're talking about the delivery of cloud resources, so that connected abstracted, and managed, as opposed to running on bare metal. So that's the first thing. You really need a virtualization layer. Out at the edge of the network, so I'm saying here a customer site or a cell tower, or out in the access network, so pretty far out, and using those resources for both standard compute loads, that's what I was talking about before, microcloud, as well as for communications infrastructure. So it's the cloud benefits, the connected, abstracted, and managed, out at the edge of the network, used for both comm loads as well as normal business workloads. Does that make sense? I'm also distinguishing a little bit from, you get back in a little bit further in the network, what people talk about as telco cloud.
So there's no UCPE in this picture, right?
I would say that well, I'm not showing the UCPE, these are the locations, but the UCPE would be sitting at any of these places here, at the enterprise, the SMB, at the RAN. Could be, yeah, I should have drawn some little, this is a fairly new picture, so I need to go back and edit that. Got to show what I'm actually selling. All right, and so for the, for the first really good question, we have a really groovy prize from my pal Vishal here. So,
thank you.
That's what's known as a bribe. All right, so here's another way of looking at it, and this is getting a little more into the detail. So this is what we're looking at as a kind of a standard stack up. So at the bottom, you've got a UCPE server, and today it's almost all Xeon and Atom. And we get questions about ARM. We do see ARM as coming on as a viable solution, but right now there's not that much difference in the cost, and the support infrastructure for the Intel architecture processors is just so much better in terms of the software, the availability of the white box servers, the ability to get the VNFs running on that. Those are all much broader today. So, but from a customer standpoint, from our customers know that when we deliver an ARM version of our software, which is that ensemble connector in the middle, that will abstract away any differences between Intel and ARM. So from them, it'll be transparent. So that's one of the benefits of having this virtualization layer as opposed to running bare metal. And that's what we're providing, the NFVI software and network OS. And I'll go into a little bit more detail on what that is later, but we're providing the layer of abstraction. Now on the right, you can see that today's services with the SD-WAN, WAN optimization, firewall, unified threat management, IDS, all those types of things. I show running in a VM, that's today. We do support Docker. We run some of our applications in Docker, and as the VNFs become available, they will also move into Docker. And as I said, the first interesting instantiations of those are the virtualized test agents. But then if you look over to the right, this is where it gets really interesting, where you start innovating without having to change your hardware. You can innovate by putting new software on there. And that's why I like that picture, that original picture so much, showing the apps coming down from the cloud. It's like your smartphone. When you want to add a new app, you don't have to upgrade your smartphone, you just put a new app on it. And what that has done by creating an open platform for innovation, it unleashed all these applications that nobody was even thinking about. So another variant is wholesale services. I mentioned Masergy, and when we started working with Masergy all those years ago, Tim Narramore, their CTO, said, look, my model is I want to replace our standard service offering, which is an Ethernet NID, a router, and a firewall. 3 boxes. That's our standard offering. And when we show up at the customer, they say, are you guys a telco or a pizza delivery service? Because they're coming in with these big boxes all stacked up. It looks like the pizza guy coming. And they go in, they chew up a lot of space in the wiring closet. He said, I want to move away from 3 boxes to 1 box. Replace all those boxes with software running on a standard server today. Tomorrow, I would really like to go from 1 box to 0 boxes. What I would like to do is, and understand, they're a managed service provider. They're not a facilities-based provider. When I go to Verizon and say, hey, Verizon, give me a circuit to whatever First North Street, San Jose this is, I would like him to say, hey, would you like a managed hosting for your VNFs on that? So Verizon would come in, drop a UCPE server, spin up a soft NID for the connectivity, and then give Masergy, the over-the-top provider, the ability to run a VNF to give an end-to-end service. So Verizon gets incremental revenue from a managed server. The overlay provider does not have to send a box. They don't have to send anybody on site. They just spin up their VM, providing SD-WAN or firewall or whatever, and the customer gets their service. That's great, but think how great that is when you're deploying on 6 continents. And now you don't have to worry about shipping 3 boxes to your customer who's got offices in 6 continents, including places like Brazil or Russia where it's hard to get stuff in. Instead, you just work with a local service provider. It fundamentally changes how we think about building networks. I talked a little bit about the end user applications. We actually are seeing cases where the end users are realizing that because they're getting their service in a white box, they want the operator to give them that VM to spin their applications on. So it's not a push, it's a pull. Hey, Mr. Operator, give me a virtual machine. I know how you're building this. Give me a virtual machine because I need to run stuff there and I don't want to put in another computer. And then in an extreme case, the store in a box, where you put not only the communication services and the applications and the point of sale and ATM and everything else collapses into one, so you have one hardware box supporting the needs for a site. All right, promise some real world use cases. Let's look at them. So here's one, universal CPE for energy multinational. And we were working with one of our partners to deliver this. And one of their considerations was they wanted to have the ability to support deployments worldwide. So that narrowed down the set of potential providers for the hardware. They had certain third-party VNFs they wanted to use. In this case, they really were already using Palo, Riverbed, and Versa, so they wanted to stick with those. And this is another real benefit for the operator for universal CPE. If I'm looking at rolling out an SD-WAN service, I don't have to go and look at the top 6 VNF supplier or SD-WAN suppliers and pick one and say, okay, we're going to roll this out, and this is our dedicated solution. I can roll out a universal platform and say, okay, you want Versa? Fine, I'll give you Versa. You want Silver Peak? Sure, I'll give you that. You're a Cisco shop, you want Viptela? Hey, there you go. So you give the customer what they want instead of trying to tell them what they want. And the former works a lot better than the latter. In this case, another feature that was interesting was the reliability. We have the ability, and there's a typo there. I hate that. And you know, these things normally jump out. It runs me up the wall, so I apologize for that. So anyway, they needed network high availability beyond the scope of the SD-WAN, so that's something we can provide. And then open and economical MANO. Now you'll see later that we provide a set of components including the NFVI as well as MANO. These are decoupled. So when we work with some of our customers like Verizon, they use a third-party MANO. Other ones like Colt get a complete solution from us. Either is fine with us. All right, let's talk about here's another one, a financial. And for them, they, in particular, were a Dell shop, and they wanted to move to Dell. So that's fine. We partner a lot with Dell. One of the things that I want to point out here was the 4th item there, the simplification of IT infrastructure. We have software encryption that we can run. So rather than having to have an external encryptor, we can run the encryption in software, and that can also land in public cloud infrastructure. So you can get end-to-end encryption running in software, independent of anything else in the architecture. And this customer had been reading a lot about virtualization, and they had read all the warnings that I listed earlier. So they said, okay, we like the idea of this, show us it can work. So we worked with our partner to go in and do performance testing and show that it could meet the requirements and that it could give them the benefits they wanted. This enterprise microcloud we've talked a little bit about, and in this case, I just want to point out there's 2 ways that this can work. So one is that if you, actually I'm going to hold that thought for the next slide. Yeah, this is, I think this is going to be a fairly popular option because when you're looking at these public cloud infrastructures, they're all talking about moving to the edge. Like if you look at Microsoft Azure, they've got this Stack offering. Today, Stack is, I think the minimum deployment is 3 big honking servers that goes on the prem. But the benefit is, you can, if you're an Azure customer, you can make your local applications look just like your data center applications and move them back and forth based on load and cost and latency. If they moved that big stack infrastructure down to a VNF or a VM, now you can see that they could offer an end-to-end solution scaling way down. So for this office in a box, store in a box, whatever model, they can make a pitch. Hey, you can do hybrid computing. You can host your jobs here or on your own site and move them back and forth, and we can make it really easy for you. And this is one that we're starting to see a lot in terms of the IoT gateway. And this is where I want to mention two options. So one of them would be that, so first a point about the IoT. A lot of the implementations of IoT consist of the devices and then some type of a gateway, and then you're pushing traffic back into the cloud. So the gateway can run in a VM or a container. This could be offered as a operator service. They can say, okay, I'm going to come in and give you SD-WAN and firewall, and I'll run an IoT gateway for you. Or this could be an overlay where the operator has got nothing to do with the IoT. They're just giving a VM and the customer's running the IoT. They can both work. All right, so I've talked some about the drivers. I've talked a little bit about the use cases, and I asserted that this is real. So I'm going to show you how this is real and how we build it. And this is showing our components and where they sit. You can see up the top, there's two green boxes. Like that green? That's where that green came from, my tie. This is all done by, you know. At any rate, the top level are our orchestrator and our virtualization director, which handles things like the zero-touch provisioning. And then you see the VNFs, and then you see our VNF software, or excuse me, NFVI software, a connector with the little octopus arms, and then running on the COT servers. And we hit really 3 points. We say, why do you need something like this as opposed to just loading up Ubuntu or CentOS or something? And it's networking, operations, and choice. We've talked about the networking, the need to have the layer 2 and layer 3 networking. One of the features we have, we can run a carrier Ethernet NID in software. So running our software on a standard server with no special hardware, you can take and designate one of the gig ports as a uni and present traffic coming out of there that fits a carrier Ethernet 2.0 interface. It's got the tag stack and the P bits and the shaping and the policing and all the other stuff without having to have a different box. The operations, this is making it deployable, the zero touch, we say all cloud deployment models we can run with a OpenStack controller running on the box, or you can go in and directly manipulate the VM. So with the OpenStack controller running on the box, we call that a microcloud because it does act like a cloud in a box because you've got both the controller and the agents all in the same box. So any orchestrator that can talk to OpenStack can manage that box, can manage the service chains. Also things, the fault performance troubleshooting and upgrade management. If you're used to dealing with network devices, you know the standard model is you've got the running software and the fallback software, and you upgrade the inactive, and then you switch over, and if it croaks, it switches back, and all that stuff that we've been doing in telcos for forever. We have all those features in here, so if you push a software upgrade down to the box, you switch over to it, and if it doesn't work, it falls back. All that functionality is built in. And then finally, choice. I'll show you the virtual network functions and the compute platform, open and neutral, and that means that you can work with all these different software suppliers, all these different hardware suppliers. We can onboard the VNFs, but what's really interesting is now our customers are onboarding the VNFs. And because it is a standard cloud environment, it doesn't even have to be a VNF. And by VNF, I mean something that's talking about networking, SD-WAN or firewall. If you're running an accounting application in a VM, that's not a VNF, that's just a standard workload. And you can spin those up whenever you want. So here's a sadly out of date, and every time we create one of these, it's out of date as soon as we publish it, list of some commercial VNFs. And really the point of this is just to see all the people we're working with. Now, if you look hard and you know our business, you will know that some of the names on this chart are people that we compete with in other fields and even in the field of NFV. But guess what? That's the new reality, that we have to work with people in this environment, and we're going to compete with them in that. That's fine. Our portfolio of COT suppliers. We work with a lot of these guys. And if you look in the lower right, we also have our own hardened platforms. Now, we don't sell those as much as these other ones, but they do have capabilities that are not in the other ones. But you know, we offer our customers a choice. If they need those hardened devices, timing, sync, whatever, we'll work with that. If they say, we love Dell, that's fine, we'll work with them.
You don't have Cisco on this one, okay.
What's that?
You don't have Cisco, okay.
Cisco UCS? Yeah, we can run on that. We can run on Cisco UCS. We're serious. And did you know there was Cisco on there? Cisco on the VNFs? Both Cisco and Viptela.
Yeah.
All right. Now, I promised I would finish on time, so we're way ahead of schedule. So we got plenty of time for some questions, and there might even be some more prizes. But what I am asserting here is that both service providers and enterprises are looking to this cloud model, this UCPE model, to bring the power of the cloud to the edge of the network, and that's why we call it edge cloud. What really kick-started the deployments of universal CPE was SD-WAN. That was a case where you had demand from the customers and the desire of the operators not to put another appliance in the network. So those two coming together really drove UCPE. But now that people are starting to roll it out, they're realizing, hey, this is great today, but it's even better tomorrow. It unleashes this innovation, cost, and speed. And then, you know, the sales pitch here is that we have been at this now for over 5 years. We have deployments, and we can help not only with the technology, but the sales enablement. How do you explain to your sales guys who are moving from selling simple connectivity services to complicated and advanced managed cloud services? How do you make them, how do you help them make that turn? How do you fulfill the service orders and turn-up logistics and the professional service and support? And to that earlier question about integration, we can help with that. Third parties can do it, or operators can do it themselves. We'll work with people however they want to work. So this is more than replacing appliances. This is really all about the power of the cloud. And that's why I started with that picture. Think about the beginning, think about where you're going, and it helps you get to where you want to be. So we got a ton of time for questions. We got 3 over here, so.
Can you hear me?
Yep.
Can you use the mic?
Use the mic.
Oh, use the mic. Okay, sorry. Hi. You mentioned LTE as your connectivity. With
An option.
An option with the 5G and potential millimeter wave issues indoor. Are you going to support, or I just want to hear your view on 5G. You think it's going to work, or how it's going to work for you guys? And the second question would be security.
Okay, so to the first, so one of the benefits of working with these off-the-shelf platforms is they have standard interfaces. They've got gig and 10 gig Ethernet ports. They've got USB ports. They've got PCIe slots inside. So if somebody comes up with an interesting application that we've been talking with some partners about 5G, where potentially you would be using, I forget the name of the interface, the gig interface to the actual radio. So the radio would not be within the box. LTE could be in the box. And if you look at some of these, partners we're working with, actually there's antennas on the back of the box. So if you're in the right location, you could use the internal antennas. You could come out to an external antenna. So the answer is we really don't care, because we're supporting whatever the hardware can support. And typically to us, it's just a driver, PCIe interface, or even gigabit. So, and the second one was about security. What what about security?
So security in terms of when you're talking about cloud,
Yeah.
Use universal CPE devices, what kind of communication is happening between the two of them?
Okay, all right, so that's a great question. So as part of our zero-touch provisioning, there's a couple of different models we can support, but kind of our recommended model is that you would send a box that is customized for, so let's say you're an operator. So the box is not customized for the customer, it's customized for your network. And that is, the customer could you could drop ship it to them, from the manufacturer, so it never hits your warehouse, shipped to the customer. You would send them an email. They would have ordered service. You would send them an email of a code to enter. So when the box came in, they would attach a PC or attach with the Wi-Fi, enter the code, and what that does is identifies the box. So the whole back-end system knows that a customer is going to enter a code from this address. And that's how you assure that even if the box got to the customer, but then the neighbor picked it up and stole it because it was too close to Christmas, that you don't have a live box that's going to go on the network. So the customer would enter the code. It would establish first management tunnels, secure management tunnels, and then those secure management tunnels would be used to allow the orchestrator to come in and spin up the service chain. Now the service chain would typically include something like SD-WAN, which would create customer encrypted tunnels. So the management encrypted tunnels would be coming from the zero-touch process. The customer encrypted tunnels would be coming from the VNFs, and then our built-in routing and NAT would take care of the case where you're on broadband and you only get a single IP address and you have to multiplex those. So is that, okay? Close enough. Well, hit me later if you want more. Yes?
What would be your plans to put in standard APIs on top of your Mano?
On top of the
Operations
orchestrator?
Management, yeah, your zero-touch management. Because right now they're proprietary. And, proprietary means that you get to change them every time you support a new thing that goes underneath, a new software and so on. It means that there's a new APIs, there's a new this, there's a new that. And so having to understand and do the translation and system integration to adapt to everything would be great if you were to offer standards northbound APIs, that you then get to do your own adaptation for whatever is needed behind it.
Well, so I would beg to differ a little bit. I mean, at the top we're talking to standard interfaces like Radius and TACACS for security and.
No, I'm meaning from a configuration or from an alarm or a troubleshooting perspective, right? So when you're receiving
we're using, well, so there's a variety. We are using netconf and yang for configuration. So I would say that's a standard.
That's below you. I'm talking about your northbound interfaces.
Well, I think we're talking past each other. So let's take this offline because you're talking about Mano, you're talking about alarms, and you're talking about ZTP. And those are all kind of three different things that.
Yeah, I'm talking about from the OSS side coming down, and as well from your Mano as responding northbound into troubleshooting and things like that. So.
Okay.
Okay.
Somebody else had a question.
Okay, this universal CPE is a nice idea, but you see the cost of the UCP, like for the major of the enterprises, SMEs, right? So what do you think about the proposition of a thin CPE, like just deliver a very thin device, maybe a layer 2, and host all the applications in the SP cloud in a very standard and,
Sure.
more control?
That works in some applications. So if I have a SMB and all they need is some simple connectivity. So if you're able to do traffic classification and some type of encryption, that might be enough. But if you want any type of SD-WAN with the ability to support multiple paths or fall back onto LTE, you need more sophisticated functionality on site. If you want a firewall, if you look at my office, we have a local firewall, but we would be just as well served with a cloud-based firewall because we're only concerned about internet threats. But if I'm a bank or a hospital, I'm worried about somebody sniffing the cable. And all that traffic needs to be screened and filtered before it ever gets out of the building. If you need that, then that functionality needs to run there. If we talk about the store in a box, where I want to have all these other miscellaneous applications running, I need compute there. So it goes back to my original point of the centralized versus the distributed. They're both valid. We don't have a theological adherence to one or the other. Put the functions where they need to go based on the requirements of the service and the availability of resources. So they're both valid models.
But there is a commercial reference for this thin CPE. There is some commercial reference, like you have implemented this solution somewhere?
So we have some cases where we're running functions like our software encryption that's back in the cloud coming off of a thin device at the edge. Most of the applications that we're pursuing, I mean, I'll be very, very honest, our sweet spot is the thick CPE, the universal CPE. That's the problems that we have solved. Now, with our very capable hardware NIDs, our carrier Ethernet NIDs, they can do encryption and classification. I mean, essentially, they're what you're talking about. Those exist. Oh, we got one over here. We still got 4.5 minutes, so I'll get back to you.
Okay.
I promised I was going to finish on time.
So I have two questions that may be related. So early in the conversation, you talk about you pick your own hardware, you pick your own operating system, whether the Versa or Vipatello and the others, and then you can pick your application. It could be one of the NFV. And the question is, who is ultimately responsible for testing the integration for the solution? Is it the customer or is it one of the vendor?
Well, it depends. So if working with Verizon was the integrator. So Verizon was working with the hardware suppliers and all the VNF suppliers, put us in a room, beat on us and say, guys, make this work. So we all have to cooperate. For the smaller operators, we would see the opportunity for integrators and SIs to come in and bring a solution. That's what they do today. They take hardware solutions and integrate them and bring a turnkey solution with best-of-breed components. Well, I'll see the same thing occurring on the software side. We're working with IBM. IBM sees this as a tremendous opportunity to take and address the needs of these large multinationals that want a more modern solution but don't have the wherewithal to integrate it themselves. So an IBM would take our software and software from Versa and Viptel and Silver Peak and whoever and get hardware from whoever made sense, HPE or Lenovo or Dell, integrate the solution and deliver it to the customer, possibly as a turnkey, possibly as part of a managed service. So is that what you're asking?
Yes. So with that diversified integration model, could be the service provider, could be the system integrator, and then can you talk about your post-sale support model?
Sure, and that depends on which of those it is. So if we're working with a tier one, they're doing the first level of triage. They've got their experts, and they would then kick problems back to us. Now, of course, a lot of it, because of the nature of these solutions, sometimes it's hard to tell where the problem is. So we're starting to add more capabilities to our software to help triage these problems and say, it's probably this VNF. We see packets going in, but none are coming out. We think that's a problem. Dump that out and then use that to handle the problem. For the SIs, well, whoever's acting as integrator, they're really going to be the first point of contact. They're going to have to do the triage and then distribute the issues based on what they find.
Thank you.
Got 2 minutes.
Wait, so in case of software upgrade, wait for the microphone.
Thank you, Dan. In case of software upgrade, is that a push-pull? I guess this is a push from the server to the...
It's a push from the server.
Right.
And we're running CentOS under the hood.
Right.
So we can have varieties of updates. It could be installing a new application. It could be a patch, or it could be a full new kernel distribution coming down.
Right. So sorry. The
Go ahead.
second question, actually, because we are running out of time. So if it's a complete NFV upgrade, how long does it take in average based on your experience? That's it.
So, well, it depends on how much is being upgraded. So, like, for example, one of the things that we can also do, I want to mention, is that we're running the OpenStack in a container, so the OpenStack controller. So we can upgrade the OpenStack completely separate from the rest of the software. So it's much more like a VNF. So you decouple those two. So the download can occur in the background. So you can download it in the background just like you would any other network appliance. And then when you boot up in the new software, it's just like any other boot up. So
Is that a multicast? Is that push to all the clients?
it's a push to it's a SSH, or excuse me, SCP or SFFT, whatever your transfer method is, to push it down. And sorry, what was the question? I got lost.
Multicast, if you have
Oh,
multiple
no, yeah,
clients.
so it's a unicast. So you're pushing each unit down.
Right,
So
that's it. Thank you, sir.
it's just the nature of how telco networks are run. Is that it? All right. Thank you very much, and thanks for the great questions.